Hey, good morning, everyone. Today we will be discussing two lectures, in rotation and torque. Okay. So first, for lecture 21, we have energy in rotation. Here, we will define what is moment of inertia, and then calculate moment of inertia about a given axis given multiple objects in the system. And then we can apply conservation of energy in rotational motions. And then discuss an extension of this, which is the parallel axis theorem. Okay. Rotational kinetic energy is given by this equation, K equals 1/2 I omega squared, where I is the moment of inertia and omega is the angular velocity or angular speed. Notice that this has a similar form with the linear kinetic energy or the kinetic energy in linear systems, which is K 1/2 mv squared. So recall this is for the linear systems, right? So linear systems, right? And makita natin ngayon yung analogies with each other. So sa linear, based siya sa mass, right? It's proportional to the mass, but the rotational form is proportional to the moment of inertia. Okay. So kaya technically, before, tinatawag din yung mass as moment of mass to coincide with moment of inertia. Okay. And then we have this linear velocity, which corresponds or analogous to the angular velocity. Okay. So parehas lang form, parehas may 1/2, parehas naka-square yung velocity, etc. Okay. So this is the rotational form or the rotational correspondence of the kinetic energy. Now, what is this I? This I is the moment of inertia. And it can be computed in two ways, in two major ways. Right? For a discrete distribution of particles, for example, like this one. Let me change. Example, this one. For this discrete distribution of particles, we can compute for the moment of inertia using a summation. So, for example, meron kang ganito, meron kang particles, gusto mo makuha yung moment of inertia of this, we just, about this given axis, so sabihin natin ito yung axis, right? Yeah. Sabihin natin 3D. Okay. So sabihin natin about this axis, z-axis, right? This is x, this is y. Okay. So if you want to get the moment of inertia about that axis, then we have to find or sum the mass of each object or the mass of each particle times the distance from that axis. So this is now your R. So inyong R. This is your R. This is your R for that example. Okay. So isasama mo lang yan. Yung M1 R1 squared plus M2 R2 squared. So magiging M1 R1 squared. Ito. This mass 1. Plus M2 R2 squared. Plus M3 R3 squared. Hanggang umabot ka kung ilan man yung particles. So kung marami yung particles na yan, maraming particles. So isasama mo lang siya na isasama. So yan yung for discrete. Okay. Now for a continuous distribution such as this one, kailangan mo nang gumamit ng calculus, which is integral form. Okay. So the integral form is the integral of r squared dm. So for example, gusto mo yung, sige, sabihin natin yung solid cylinder. gusto natin kuhanin yung moment of inertia along this axis. Sabihin natin yan yung Z. Ay, masyado mataas. Okay. So, yan yung Z. At meron ka pa rin X and Y. Okay. So, X and Y. So, if you want to get the moment of inertia on this axis, the Z axis, then we have to integrate or we have to consider an infinitesimal mass. For example, this infinitesimal mass, right? And then find its R, the distance from the axis. So yung R dito laging distance from the axis. Okay. Kung saan siya magro-rotate. So yun lagi yung definition ng R. So kung dito yung dito natin pinaparotate sa z-axis, then this is the distance R of that infinitesimal mass dm. Okay? And then you integrate. Okay. However, meron naman tayong given na equations for geometric shapes, for simple geometric shapes, okay, or 3D geometric shapes. So, hindi ko na i-discuss kung paano nakuha tong mga to, pero nasa naman sila, nasa Young and Friedman or University of Physics. But here we have two cases for the rod, right? Slender rod with the axis, the rotational axis through the center. Okay. So kung through the center yung axis mo, then yung moment of inertia is given by this, where L is the length of the rod. If yung pivot or yung rotation axis mo is through one end, then you will use this one. Okay, so magkaiba yan. Magkaiba to. Same with a rectangular plate. Okay, so kung may rectangular plate ka na sa gitna yung rotational axis, then you will use this, that moment of inertia. Pero kung ang axis is along edge, so kung dito mo pinapaikot, okay, then you will use 1/3 ma squared. Okay. For hollow and solid cylinders, so and thin-walled hollow cylinders, so meron kang corresponding different moment of inertia as well. So sa hollow cylinder, meron kang inner radius, R1, and then outer radius, R2. Okay. Sa thin-walled and solid cylinder, hindi mo naman siya kailangan. Okay. Isang R lang yan. And sa solid sphere and thin-walled hollowed sphere, meron ka namang different coefficient, 2/5 and 2/3. Okay. So the question na lang is when it is appropriate to use. When is each of these is appropriate to use? So depende ngayon yan sa system. Okay. Before we provide examples, let's discuss the extension of this, which is parallel axis theorem. So whenever you want to find the moment of inertia from a given center of mass, you can use parallel axis theorem. For example, we have this solid cylinder. Okay. So alam natin from before, slide before, kung solid cylinder, kung ang axis ay nasa gitna, ang moment of inertia niya is 1/2 mr squared. Okay. So if ito yung axis niya, kung dito yung axis of rotation, then wala tayong problema. 1/2 mr squared lang siya. Right? Ay, tama ba? 1/2 mr squared. 1/2 mr squared. Okay. However, kapag yung rotational axis ay wala sa center of mass, like a distance d, like this one, from the center of mass, ito na yung bagong axis of rotation. This one. So that yung solid cylinder is nagro-rotate along this O ganyan. Then, hindi na applicable yung 1/2 mr squared. What we have to do is to add a fact of term md squared, where m is the mass of that object na na-offset, and then d is the distance from the distance ng center of mass, from the rotational axis. Okay. So again, this is this theorem extends if yung axis of rotation mo is hindi na along the center of mass, or at least hindi along dun sa mga given kanina dito. Okay. Okay. So halimbawa, yung axis of rotation mo nandito na for this thin-walled hollow cylinder. Eh di kukunin mo ngayon itong distance na to. Ganon din dito. So kukunin mo yung distance na yan, yan yung i-add mo ngayon dito. Plus md squared. Kung ano man yung distance na. Okay? Same with all the other cases. Okay? So kaya siya tinawag na parallel axis theorem. Kasi parallel yung axis. As long as yung rotational axis mo is parallel to the center of mass axis nung object, then you can use this parallel axis theorem. You will add additional term. Okay. So yung total moment of inertia will be yung inertia of the center of mass, 1/2 mr squared, plus md squared. Okay. So ganun siya nag-work. Okay. If i-try nyo i-apply, so this is a homework, if i-try nyo i-apply yung parallel axis theorem from A, makukuha nyo yung equation ni B. I guarantee you, makukuha nyo yung equation ni B. Okay. So, halimbawa, ito, 112 ml. Ito yung through the center of mass. Right? Paano to? Nasa gilid. Diba? So, alam ko, mag-a-add ako ng md squared. Yung m, same lang naman yan. Same mass. Right? But yung d, kung nandito na yung axis of rotation ko, is this distance, which is L over 2. So, magiging, ito, dito natin ilagay sa taas. Magkakaroon ka na ng 1/2, 112 ml squared plus, hindi na pala homework kasi sinagot mo, d, which is L over 2 squared equals, meron kang 112 plus, ito magiging m L squared over 4. And what's 112 plus 1/4? That is 1/3. Tama ba? 112 plus 1/4. Yeah, 1/3. So makuha mo dyan. So ito 112 ml squared. So magiging 1/3 ml squared. Okay? So pwede yung exercise ngayon is to get this. Dapat makuha nyo ngayon etong equation na to if you apply parallel axis theorem here. Actually, hindi pala. Hindi pala siya parallel. Perpendicular. Never mind. Okay. Pero yun. So, ito nakuha using parallel axis theorem from here. Okay. Meron din namang perpendicular axis theorem, but it's a more complicated way to get this one. Pero hindi na yun scope ng topic natin for today. Okay, examples or exercises. And I suggest that you answer this as we go on. So, hindi yung makikita nyo na agad yung answer or like tutuloy-tuloy na yung video. Pero I suggest na sagutan nyo muna or pause nyo muna yung video Then answer it on your own and then find out if you're right or wrong. Okay? A frictionless pulley has the shape of a uniform solid cylinder of a mass 2.5 kilograms and a radius 20 centimeters. Ito yung pulley. Meron siyang radius. Siyang radius 20 centimeters. Okay. Now, there's a stone of mass 1.5 kilograms attached to a very light wire and is wrapped around the rim of the pulley and the system is released from rest. Okay. So, pag sinabing very light wire, ina-assume ngayon natin na itong wire ay massless for easier calculations. Now, first question, what is the velocity of the stone after falling 2 meters? So, from here, nag-fall daw siya ng 2 meters. And what percent of the total kinetic energy does the pulley have? So, ano ngayon yung percentage of from the total kinetic energy meron yung pulley? Okay. So, yun yung questions natin. So, first, sigot na. Okay, sige, okay lang yan. So first, what is the velocity of the stone after falling 2 meters? Okay. So for this, we have to use conservation of energy. Again, it's much easier to use conservation theorems rather than kinematic equations. So since alam na natin yung mga conservation theorems, then we just have to, okay, solid cylinder pala siya. Solid cylinder. We just have to use conservation of energy. Okay. So meron tayo ngayong kinetic energy ng stone habang siya ay nahuhulog. Right? So ito yung cylinder. Right? So may attached na wire, ito yung stone. Okay. So may kinetic energy si stone habang nahuhulog. Meron ding kinetic energy si pulley, which is the rotational kinetic energy. So note na si stone meron siyang linear kinetic energy, but pulley has a rotational kinetic energy. And then we have potential energy of the stone. Okay, so si pulley wala siyang or at least hindi natin usually kinakount yung potential energy ni pulley. Okay. And then, so you have this for the initial state, and then this for the final state. Okay. And if we write the equations, we have 1/2 mv squared, 1/2 I omega squared for the rotational, and then mgy for the potential energy of the stone. Okay. Now, sabi dun sa problem, it starts from rest. Right? Released from rest. So meaning, wala kang velocity sa start. So v equals 0. Wala ka ring omega sa start. Kasi hindi pa umiikot si cylinder. So wala ka pang rotation kasi start from rest. So omega is 0. So these terms will cancel out. Now, pwede nating iset na ito yung y equals 0. Right? Pwede nating iset na this distance is y equals 0. So that mawawala na to. Okay. And gusto nating makita yung y equals -2. Kasi nag-fall siya ng 2 meters. So kung sinet natin itong y equals 0, then 0 na yung left-hand equation natin. Kaya 0 to. How about sa final state? Okay. So sa final state, meron tayong velocity or kinetic energy ng stone. 1/2 mv squared. And v, ito yung hinahanap natin. Yung final velocity ng stone. Okay. Then we have rotational kinetic energy of the pulley. So 1/2 I omega squared. Okay. So 1/2. Yung I is the moment of inertia for a solid cylinder given is 1/2 mr squared. And then omega, remember, omega is the angular velocity, which is just velocity, a linear velocity over the radius r. Okay. So V over R lang yung omega. So we have this now. Plus yung potential energy ng stone at the final state. So with this, we isolate now V2. Okay. We isolate V2, the velocity squared. Okay. So meron ka ditong, let's clear everything up. This is blue. So ito magiging 1/2 mv squared or V2 squared plus you have r squared magka-cancel. So meron kang 1/4 m. Again, magkaibang m to kasi ito ay mass ng stone, ito ay mass ng pulley. Ito naman ay mass ng stone. M V2 squared plus mg y2. Okay. So with this, we can combine this 1/2 plus 1/4. 1/2 m plus 1/4 m. Tapos yung mgy2 pupunta sa kabila kasi 0. Kakaroon ka ng negative mgy2 equals 1/2 m plus 1/4 capital M v squared. And then, bababa ngayon itong term na to. Kaya meron ka dito negative mgy2. Ito yan. Tapos, ito ay bababa. So, ito yon. And then, since v squared, kukunin mo yung square root. Okay. Ngayon, meron ka dito square root ng negative. But don't worry kasi si y2 mo, nung sinet natin kanina, magiging negative 2 meters. Okay. Kasi, sinet nating 0 is yung at rest. So, dito yung y equals 0. So, kung nag-fall down siya dito, that will be y equals negative 2. Okay? Plugging in our values and to check, dapat yung makuha velocity is 4.63 meters per second. Okay. So, question. Bakit yung velocity na ginamit natin for the cylinder ay same dun sa velocity ng stone? To answer that, kasi in contact sila. Again, remember from kinematics, right? From your lectures 2, 3, I think, for kinematic equations, right? Or kinematics. Whenever there are objects that are in contact with each other, kung ano man yung velocity or acceleration nito, yun na rin yung velocity and acceleration nung kabila. Okay? Unless meron kang additional forces. Okay. So dito, sa problem na to, ano lang naman yung force na nagko-connect sa kanila? Tension. Diba? So meron kang tension from the stone to the pulley, meron ka ring tension from the pulley to the stone. And those cancel out. Diba? Yung T of stone to the pulley and T of pulley to the stone, they both cancel out because of Newton's third law. Okay? They are opposite pair or action-reaction pair. And so, we can say that kung ano man yung velocity nito, yun din yung magiging velocity nito. Although, hindi umiikot ngayon, ay hindi literally gumagalaw from its place si cylinder or si pulley. Nagro-rotate lang siya. Pero yung linear velocity nung string na nandun kay pulley ay na-convert into the rotational velocity nung cylinder. That's why we can say that they have the same linear, quote-unquote, linear velocity. Okay. Okay, so yung linear velocity na to ni stone, na-convert into the rotational velocity or angular velocity because they are both in contact with each other. Okay? Nagka-cancel out lang itong tension because of Newton's third law. Okay? Ay, meron palang ganun. Okay. Next, what percent of the total kinetic energy does the pulley have? Okay. So, again, from before, may dalawa tayong kinetic energy. Kinetic energy ni pulley and then kinetic energy ni stone. So, this is your total. Ito ngayon yung total kinetic energy. Right? Kasi dalawa. Okay. So, to solve, syempre gagamitin natin si final state kasi yung initial state, puro zero lang naman. Okay. So, final state, yung total kinetic energy, right? And then, ito yun, yung total kinetic energy ni stone. So, meron ka ng, alam mo na yung V, right? So, ngayon, ipa-plug in mo na kay 1/2 mv squared. So, ito nakuha using 1/2 mv squared. Ito nakuha using 1/2 I omega squared, which is 1/2 I v squared over r squared. And given yung mga yan sa problem kanina. Okay. So you can now get the total energy. You can also get this kasi nga alam mo na to. And then we just have to get the percentage. So i-divide lang natin. Or kukunin lang natin yung ratio. Okay. So we take the ratio of the rotational kinetic energy of the pulley with the total kinetic energy. And makita natin, resulting is 45.4%. Which means almost half ng total kinetic energy is actually nandun sa pulley. Okay? So anything kapag meron kang pulley, almost half, or at least in this case, because of the ratio of the masses, di ba? Merong percentage ngayon ng kinetic energy na galing kay pulley. Hindi lang kay stone or hindi lang dun sa nakabitin. Okay? Okay. So, next example. What is the moment of inertia of this system below? Consider the mass of the connections to be zero. So, meron ka ngayong distance between each masses, 0.4 meters, and the mass, which is 0.2 kilograms. Okay. And now we are considering itong connections na to be massless. Okay. Para negligible. Ngayon, meron tayong axis O sa gitna. Okay, so we are now considering two cases. What if yung rotational axis natin is in this O perpendicular to the plane? And B, about an axis parallel at a distance of 0.4 meters from the axis O. Okay. So let's answer A first. About an axis perpendicular. So kung perpendicular to the plane, then ito yung plane. Yan, yung nasa page mismo. So yung perpendicular is yung palabas. How do I draw that? Dito na lang. Yan. Palabas ng plane or palabas ng screen. Yun yung axis of rotation. So, ito ngayon, alam natin mag-rotate siya into that way. Okay. So, ganun yung rotation. Okay. So, again, we have discrete particles. So, kasi hindi naman natin kino-consider yung connections. So, to get the moment of inertia, we have to use the summation. Okay. Summation from 1 to 4 kasi 4 lang yung particles. mr squared. Okay. And since similar lang lahat sila ng m and ng r, or at least ito yung r nila, so note na yung 0.4 meters, hindi pa yan yung r. Yan lang yung distance between each masses. But the real r na gagamitin is yung distance from the pivot axis or the rotational axis. Okay? So, yan yung r natin. So, paano natin makalculate yung r na yan? So, we use Pythagorean theorem. Okay? So, meron kang triangle. Right? Nandito lahat ng mass sa dulo. So, we know that this is 0.4. This is also 0.4. So, this will be square root ng 0.4 squared plus 0.4 squared. So, yan yung distance na to. Mahabang yan. Okay. So, if we get that, we will get ang distance nito, itong mahaba, ay 2 square root of 2 over 5. So, yan yung distance na to. Pero ito lang yung kailangan natin, yung half lang. So, ngayon, i-divide natin si R divide natin to by 2. So that we will get that R equals square root of 2 over 5 na lang. So, yung 2 over 2, kailangan may over 2, diba? So, magka-cancel lang sila. Okay? Pwede rin naman yung mismong, ang tawag dito, Pythagorean theorem mo is yung half lang. Right? Okay lang din naman yan. Same lang yung makuha mo. Diba? 0.4 over 2. So, magiging 0.2 na lang yan. 0.2. So, what will be this one? Yun na yung exactly R. Right? And if you apply Pythagorean theorem, magkukuha mo pa rin is square root of 2 over 5. Okay. And same yan for all particles. So, we just get 4 times mr squared. Right? Kasi mr squared plus mr squared plus mr squared, dahil similar lang naman sila, we just have 4mr squared. Okay? And then we plug in our values. 0.2 kilograms. And then, mr squared. So, ito yung r natin. 0.2, bakit times 2? Square root of 2 over 5. Anyway, dapat ito ay square root of 2 over 5. Kasi na-divide na natin ng 2. Yeah, dapat square root of 2. Maliit na maliit. Dapat square root of 2 over 5 squared. So, ang lalabas dapat dyan ay 4 times 0.2 times square root of 2 squared is 2 over 5 squared is 25. So, what? Square root of 2. Okay, same lang pala. Pinasok. 0.2 pala ay tama. Ay 1 over 5. O nga. So, same lang pala. The same lang yan. Square root of 2 times 0.2. Same lang yan pala. Okay? So, same lang din mo. So, tama pala yan. Square root of 2 over 5 equals square root of 2 times 0.2. Okay? So, yun yan. Okay? So, ang takeaway lang natin dito, again, similar yung mass nila, similar din yung r, distance, but you have to get this first. You have to calculate that first. Okay? So, wag niyong gagamitin na, ay, ito yung nakuha kong r kasi yun yung distance between the masses. Hindi yun R is always the distance from the pivot or the rotational axis. Okay? So, laging distance from the rotational axis. Okay? Next, how about an axis parallel to and a distance of 0.4 meters from axis O? Okay. So again, meron tayong axis O out of the page, right? Out of the screen. Pero, i-move natin siya about an axis parallel to that axis. So somewhere, sabihin natin dito. At a distance of 0.4 meters. So 0.4 meters. So dito na ngayon siya iikot. So ito ngayon, iikot na to around this. Okay. So ito na yung bago nating axis of rotation. So paano ngayon natin i-calculate yung moment of inertia? Again, we have two parallel axes. So we can use parallel axis theorem. Okay. So that will be the moment of inertia about the center of mass, which is at O, plus md squared. Pero, ngayon, alam na natin yung inertia about the center of mass. Yun yung nakuha natin kanina. Right? This IO kanina from A is already the center of mass. The inertia, kapag yung axis mo ay nasa center of mass. Right? So we can now use that knowledge or that value. So we apply this here, and then we have plus md squared. So again, yung d is distance from the center of mass, right? So ang distance ay 0.4 meters. So yun dyan. Ito yung d natin. Ito yung kaninang r. So that's your d. How about the m? So yung m is yung total mass nung buong system na na-offset. Okay? So that will be 0.2 times 4 particles. So you have 0.8 kilograms. Okay? So ito yung total mass nung buong system mo na displaced or na offset by this distance d yung rotational axis. And alam na natin yung moment of inertia from the center of mass. So we just have that and then apply it to our calculator, plug and play, and you will get 0.192 kilogram per meter square. Okay, remember, moment of inertia has these units, SI units, kilogram times meter squared. Okay. Kilogram times meter squared. Para malaman nyo, ay, this is something m, this is something distance. Right? So, mr squared. So, something mr squared yung formula for moment of inertia. And yung something is coefficient. Depende na lang kung ano yung shape. Right? Okay. Additional exercise. A rod, given the inertia from about the center of mass, of length 2r, and the mass m is connected to a solid sphere of radius r and mass m at point P, as shown in the figure. Okay? So meron ka ditong rod of length 2r connected to this solid sphere of radius r. Okay. Point P. Dapat point B to. Find the moment of inertia of the rod system about an axis perpendicular to the page and passing through point A, point B, and point C. Okay. So again, perpendicular to the page, meaning out of the page. Okay. So, ngayon ito ay palabas. 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 Okay. So, sa point A muna. Sa point A, wait, point A. This is point A. Right. Okay, sa point A, yung moment of inertia ng rod will be alam natin ay yung given kanina, yung given sa problem ay yung about the center of mass. Right? So ito lang yon kapag nandito yung rotational axis. Pero since nasa dulo tayo, we use parallel axis theorem. So we have this, the center of mass, inertia, plus yung displaced axis, md squared. And alam natin yung d will be just r. Okay? So 1/2 m. Yung length niya is 2r. Kaya naging 2r to. And yung displaced niya is just half of it, which is r. So we get 4/3 mr squared for the rod. Now, for the disk or the sphere, mag-parallel axis theorem ulit tayo. Kasi ito yung axis, right? Yung rotational axis. So siya ay displaced by a distance of r plus 2r, which is 3r. So, gamitin natin yung center of mass na inertia plus md squared, where d is now ito, 3r. And we get a total of 47/5 mr squared. So now, yung total moment of inertia at point A is just the sum of these two. So again, kung meron kang multiple objects, isasum mo lang yung moment of inertia nila about that rotational axis. So the total is I rod plus I sphere. Total of 161/5 mr squared. Okay? So i-add mo lang lahat lagi ng objects about that center of rotation. But note, kailangan nyo munang alamin kung kailangan nyo ba mag-parallel axis or hindi. Kung na-offset ba siya or hindi. Okay. How about from point B? So from point B, ito na yung rotational axis natin. So from point B, actually, yung I ng rod, same pa rin. Bakit? Kasi nilipat mo lang naman parehas lang naman yung distance, parehas lang naman yung mass na yan. So same pa rin yung makukuha natin for the I rod. However, for the sphere, mag-iiba na. Kasi yung distance niya na is just r na lang. Hindi na 3r. So we have 7/5 mr squared. And again, yung total is just the summation or the addition. I-add nyo lang. So magiging 41/15 mr squared. So 4/3 plus 7/5 is 41/15. Okay. From point C, ano na mangyayari? So from point C, ito na yung axis of rotation. Right? So ano ngayon yung I rod? Magpa-parallel axis theorem pa na. So alam mo, ito yung center of mass. Again, ito yung center of mass. Right? So paano siya na-offset? Ito yung distance, which is r plus r. So that will be 2r. So yung distance ng rod is 2r. Pag ganun pala dapat. Yan. So, 2r yung offset sa parallel axis theorem. Okay? For the sphere, offset ba siya? Hindi naman. So, you just use as it is. right? So distance ng offset nito ay 0 kasi hindi mo naman kailangan mag-parallel axis theorem. It's just as it is, 2/5 mr squared. And so yung total moment of inertia sa C, point C, ay yung I rad plus I sphere, which is just 71/15. Okay. So you could try more exercises about moment of inertia and rotation, especially with multiple objects. So try nyo mag-add ng objects and then try nyo hanapin yung total moment of inertia using yung figure kanina, yung table of equations, the moment of inertia. Okay. Now let's move on to torque. So here, we aim to calculate the vector product of two vectors to define torque and then relate the torque with the angular acceleration of the rigid body and apply some Newton's second law of rotation and conservation of energy. Okay. So first, we have to define or at least try an example of a cross product. So a cross product is denoted by this notation. Okay, A cross B, where A and B are both vectors. Okay. So usually, yung A and B vectors mo, 3 dimensions. So kung 3 dimension, meron siyang X component, Y component, and Z component for both A and B. Tapos yung direction is I hat, J hat, K hat. Okay. Ngayon, what you do is you draw this. Okay. You enumerate this as a table, I hat, J hat, K hat, and then we have the X components under the I, the Y components under the J, and the Z components under the K, right? And then we write at sa kanan, sa right niya, at 2 J hat again. So bakit? Kasi gagamitin natin itong process na to, right? To find the cross product. So, yung green lines, ito, dapat pala green din or other color. So, yung green lines, you have to multiply all of these, but with a positive sign. So, meron kang A cross B, A cross B equals, meron kang AY, BZ, I hat, plus, and then i-add mo yung H line, right? Meron kang plus AZ, BX, this is BX, right? J hat, right? Plus, meron kang AX, BY, K hat. Okay. Ngayon, meron ka naman itong mga blue lines na pataas. Okay. Tam. So, tatlo din yan. So, tatlong green, tatlong blue. Pero yung mga blue lines, i-multiply mo sila, pero negative. Okay. So, ibig sabihin, magkakaroon ka ngayon ng minus. So, minus bx b sub x ay k hat minus by az I hat and then minus bz ax j hat. So, meron ka ngayong 6 terms. Tatlong positive from the green lines tatlong negative from the blue lines. And yung cross product is the sum of all of these. Again, yung blue lines, ine-negate mo. So, negative sila. So, sasubtract mo sila. So, tatlong positive, tatlong negative. So, as you can see, yung A cross B, meron ka pa rin A hat, J hat, and K hat. Okay. So, tingnan natin yung final form. Ito yung final form. Okay. So, ngayon dito, meron kang dalawang I hat. Ito, saka to. So, AYBZ and BYAZ minus BYAZ. Ito yon. AYBZ minus BYAZ. Sa J hat, meron kang A2BX, ay AZBX minus AXBZ. Ito yan. And for the, clear natin yan. For the K hat, meron kang AXBY minus AYBX. K hat. So you can see na yung resulting cross product, meron ka pa rin I hat, J hat, K hat. So meron ka pa rin direction, which means the cross product of two vectors is another vector. Okay? So cross product ng two vectors will give you another vector. Kung ano man yung vector na to, sasabihin nyo na yan ng Math 21 or Math 22 ninyo. Yun. Okay. Merong mga more implications on this. Okay. But, to simplify, papakita ko na yung vector na to is, for example, meron kang A. Ito yung axis natin. Axis. Yan yung coordinate. So, this is C, X, and then Y. Kung meron kang vector A na purely on XY plane, right? And then meron kang vector B na purely nasa XY plane din. Okay. So, this is vector A. Example lang to. This is vector B. Yung cross product nila will be directed perpendicular kung nasan yung plane na yon. So, whatever this plane is, yung A and B, kung ano man plane nila, yung vector product nila will be on the plane, on the perpendicular direction to that plane. This is A cross B. Okay. So, yan yung lagi nangyayari sa cross product. Okay. That's why it is easy to use right-hand rule. Okay. So, ito na ngayon yung right-hand rule. So, first, place A and B, tail to tail. Okay. So, ito yun, tail to tail, tail to tail. And then, point your fingers of your right hand along the vector A. So, dito, right? With the palm facing on the direction of B. Now, if you curl your fingers, pag ganon, towards B, so i-curl mo yung fingers pag ganon, your thumb will point on the direction of the cross product. And you will see it's perpendicular to the plane of A and B. Okay. So dito, medyo need nyo na yung right hand rule. Again, right hand lang. Hindi siya gumagana for left hand. So sorry sa mga left-handed like me, sir. So right hand lang. So kayo malilito, right hand rule. So point your fingers on the first vector. Curl your fingers towards the second vector. And your thumb, right thumb, will point you to the direction of the cross product. Okay. Since vector yan, may direction yan, we can get the magnitude using this. Okay. Yung magnitude ng cross product, A cross B, is just yung magnitude ni A times magnitude ni B times the sine of phi or the sine of the angle between them. Okay? So yung phi na yan, ito lang yan. Sine of the angle between the two vectors. Okay? Okay. So now we are ready to define torque. Torque is a vector given by the moment of inertia multiplied by the vector angular acceleration. Okay? And it is only true for planar motion. So kung nasa plane ka lang. Take note or notice na medyo similar ito ngayon sa F equals MA. So you can see now the analogy or analogy sa linear motion and rotational motion. So kanina yung sa kinetic energy, pero kang 1/2 mv squared as compared sa 1/2 I omega squared. Right? So analogous si V kay omega and si M, si mass kay inertia. Dito, similar din. Analogous din si mass kay inertia. And A, acceleration, is also analogous to the angular acceleration, alpha. Right? So kaya sometimes torque is called, or this equation is Newton's second law for rotational objects or rotational motion. Kasi analogous lang siya dito sa F equals ma. Okay. So there are other ways to define torque bukod dyan. So bukod sa I times alpha, we can also define torque as the cross product between the radial vector R and the force vector F. Okay. So for example, here, ang rotational axis natin is this block, right? Block. The radial vector of that object, of the object na nagro-rotate, is the distance from the axis of rotation. So yun yung basis mo ngayon ng R. Same dun sa pagkuha natin ng moment of inertia, but here we have a vector. Okay? Now, if we apply a force, right? If you apply a force, something like that, then R cross F, so gagawin natin tail to tail. So pwede natin i-move ngayon si force, right? In this direction, tail to tail. Then, if you use right hand rule, R cross F, ang lalabas na torque ay pataas. Okay. Directed upwards. So yan yung torque mo ngayon. Direction of the torque. And you can see that the direction of the torque is always along the rotational axis. Okay? Para hindi malito, torque is always along the rotational axis. So siya yung magbibigay ngayon ng rotational axis mo. Okay? So saan ba yung practical examples ng torque na to? So, I think ang mabibigay ko example is kapag you try to use or screw or unscrew things. Like if you use screwdrivers, kung gusto mong papasok, right? Kung gusto mong mapasok yung screw, you curl your fingers and then direct it towards the yung papasok. Makikita nyo na yung direction dapat ng screwdriver nyo is yung direction ng pag-curl ng fingers nyo. Kung gusto nyo tanggalin yung screw, then ipo-point nyo yung thumb nyo outwards, and then makikita nyo yung direction ng screwdriver. So kung nalilito kayo kung pa-counterclockwise or clockwise yung ikot ng screwdriver, you can also use right hand rule. And that also is an application of the torque para pumasok or lumabas yung screw. Right? So yan yung one practical application of the torque and of course the right hand. Okay. Now, following from our definition of vector product kanina, cross product of vectors, right? So pwede rin natin makuha yung magnitude ng torque. right? So magnitude ng torque is just the magnitude of the radial vector r times the magnitude of the force times the angle phi between them. So again, if this is F, pwede natin siyang i-move here, tail to tail, and this will be your phi. Dito na lang. Ito yung R kanina, ito yung R. Ito yung F, di ba, na force. So ngayon yung F, pwede natin i-move here para tail to tail. Ito lang yan nilipat ko lang. And then this will be your phi. Phi. Yan. Yan yung angle between. Okay? Ayan, mas clear na yung planar motion. So only true lang to, mga to, for planar motions. Kung nasa same plane yung R and yung F. Okay. Nasa same plane yung R and F. Vectors. Okay. Examples. A beam is pivoted at point O shown in the figure. So yung axis of rotation is here out of the page. Okay. What is the magnitude of the torque due to the applied force F? Okay. Magnitude of the torque due to the applied force F. Okay. So we move that. First, we have to find the R vector. So ito yung ngayon yung R vector. Right? And that is just 1.5 meters. Okay. We can move it tail to tail para makuha natin yung angle. Again, ito yung R vector mo. Initially, yan yon. Ito yung force vector, F. Ito yung given angle, 30 degrees. Right? So, para makuha yung angle between, we have to move tail to tail. So, pwede nating i-move ngayon si R papunta sa kabila. As shown here. So, si R, minove natin ngayon papunta dito. Okay. So, again, yung motion lang is para lang magkaroon ng tail to tail. Huwag niyong iikot yung vector. Okay. So, pwede siyang i-move around. Huwag lang i-flip. Huwag niyong iikot. Huwag niyong babaguhin yung angle. So, now, if we use that, so this one, alam na natin yung angle between will be 150 degrees. Because yung total angle for a straight line is 180 minus 30, we have 150. So, dapat yung 150. Okay. So, yun. Try drawing the vectors tail to tail to get the angle between them. Kung ano man yung kino-cross product. Okay. So, now we can calculate the magnitude. Okay. So, the magnitude is RF sine theta. Right? Ala, wala yun. RF sine theta. Right? So, RF sine theta. Where R here is R perpendicular or F perpendicular. So, anything works kasi torque naman should always be perpendicular to R, to both R and F, as long as planar yung motion. Right? And again, yung R na ginamit natin is 1.5 meters. Bakit? Kalahati lang dapat kasi ito lang yung radius natin or yung distance from the pivot point or the rotational axis point. So that will be half of 3 meters, which is 1.5 meters. Okay. Yung F is as it is, 10 newtons. And then we have sine of 150 degrees. So that will be 7.5 newtons per meter. Okay. Now, the direction, pwede natin makuha ngayon yung direction using right-hand rule. Okay. So R, pointing to the right, cross F, cross nyo yung fingers nyo dito, so the direction of the torque will be out of the page. Okay. Out of the page. Dito pala dapat. So, yan yung direction ng torque. Kung ito yung x hat natin, ito yung y hat natin. So, x, ito yung x direction, y direction, then out of the page will be your z direction. And that will be positive plus or positive k hat. Okay. So again, the lever arm, yun yung ito, force and then torque. So pwede rin naman 3 fingers, pero pwede rin mag-curl, same lang yan. Okay. Mas intuitive lang yung all fingers or buong hand. Okay. Next example. Roddy the piper is repairing a pipe. He wants to loosen a knot with his wrench as shown in the figure. So, eto ngayon, gusto niyang i-loosen tong knot. So, what is the magnitude and the direction of the torque that he applies to this knot or to this bolt? Okay. So, meron kang force given, 800 newtons. Wow, ang lakas naman yan. We have this angle, 19 degrees. Angle ng wrench from this direction. And we have the length of the wrench, which is 0.9 meters. Okay. So again, better na i-drawing natin into a free body diagram or something na we can understand. Right? Oops. So, saan ba yung pivot point nito? Saan yung rotation? Right? Yung rotation ay nangyayari here in the nut, right? Or on the bolt. Right? Kasi yung itong wrench, kailangan bumaba or umakyat. Right? So, yung rotation or pivot point happens here. Okay. So, kung ito yung rotation, ano yung R natin? This is your R. So, again, R is the direction or the radial vector from the pivot point to the applied force. Kung saan mo ina-apply yung force. Okay. Same as yung kanina dito. So, dito mo ina-apply yung force. So, ito yung R natin. The vector from the pivot point to the applied force. Okay. So, here, dito natin na-apply yung force. So, we have this as our R. And then, yung force is yung downwards. Okay. So, with this, ito yung pivot point natin, right? Tapos, alam ko to na 19 degrees. Yan yung 19 degrees. Okay. So, ano ngayon yung angle between R and F? Again, we move from tail to tail. So, pwede natin ngayon i-move si F pababa. So, if we move natin si F pababa, magkakaroon ka ng R. You know this. This is 19 degrees. Tapos, pwede natin i-move si F pababa. With that, we now know that this is 90 degrees. Right? Minove natin si F dito. So, ito ay 90 degrees. So, 90 plus 19, that will be 90 plus 19, that will be 109 degrees. Okay. So, RF sine theta. So, R, yung torque natin will be RF sine theta. Or sine phi pala. Sine phi gamit. So, R is 0.9 meters. F is 800 newtons. So times 800 times sine ng angle, which is sine of 109 degrees. Okay. So anong sagot nun? 0.9 times 800 times 1 sine ng 109. Sine ng 109. That will be 680 Newton meter. So ngayon, yan yung torque nyo. Again, ang phi dapat dito is 119. Ay, 109. Okay? So, mali ito. Dapat 109. But you will get the same. Dapat 680 Newton. Okay. Almost the same. Okay. So remember, yung torque, ang unit naman niya, SI unit ay Newton meter. Okay. Ang moment of inertia, kilogram meter squared. Ang torque ay Newton meter. So yan na yung magnitude. Ano ngayon yung direction? Direction will be, ito yung R, ito yung F. So R cross F, if you curl your fingers, then ang direction niya is out of the page. Okay, so positive K hat again. So generally, out of the page ang positive K hat. Okay, pag into the page, then negative K hat. So dito, ang direction ay positive K hat. Okay. Okay, I think last example. Calculate the net torque about a point O for the two forces applied. Okay. The rod and the both forces are in the plane or on the plane of the page. Okay. So ito ngayon yung point O. Ito yung pivot point or rotation axis natin. So meron tayong dalawang force, F1 here and F2 here. Okay. So calculate the net torque. So for F1, 8 newtons. So ito yung R natin. Haba na to. It's R and this is your F1. Right? So we can move F1 here dito and we can see na ano yung angle between? That's 90 degrees. Okay. So yung phi1 is 90 degrees. Okay. Sa F2 naman, so ito ngayon yung R mo hanggang dito lang. Again, R1 naman ay, kalimutan ko, 5 meters. R1 ay 5 meters. Bakit? 2 plus 3. Okay. F2 will be here naman. So if you move this to this, you know that this is 30 degrees. So yung angle between R2 and F2 will be 150 degrees. So yung phi2 ngayon natin is 150 degrees. And yung R2 nito ay 2 meters. Okay. So again, tail to tail. And then you can find the angle between. Okay. So meron na tayong R2, R1, phi2, and phi1. So we can now use torque for each of the forces. Okay. So using F cross R or FR sine theta, the force on F1 will be 8 newtons times 5 times sine of 90 degrees, which will be 40 Newton meters. Okay. Additionally, if we set the counterclockwise to be positive, since ito yung ano, so counterclockwise to be positive. So, kung ganun yung positive, tingin, so positive yung ito, yung out of the page, yun yung positive k hat. Then, we see that F1 will be on the opposite side. Okay? So, again, ito, simplify natin dito. Ito yung pivot point. Ito si F1. Okay. If we consider yung mga ikot na pag ganito ay positive, makikita natin pagdating dito, si F1 ay opposite ng ikot. Right? So, counterclockwise, torques are positive. So, yung pag ganon. Then, yung F1 will be directed opposite of that counterclockwise. So, kaya negative yung sign ito. So, kaya ka nagkaroon ng negative. Okay? Yung F2 naman, pataas. So, okay lang naman yung torque niya. So, positive yung torque nito. Which is now 12 newtons times 2 meters times sine nung 150 degrees. Okay? Actually, same lang naman yata yun. Sine 30 and sine 150. Yep. Okay. So, sine 150 degrees. So, dapat 150 para lang consistent tayo. Okay. And that will be 12 Newton meters. And then, to find the net torque about this point O of two forces or of multiple forces, we just have to take the sum. Torque 1 plus torque 2. Okay. So, negative 40 Newton meters plus 12 Newton meters will yield negative 28 meters. And since negative siya, then ito yung magnitude, 28 Newton meters. And negative means yung opposite ng counterclockwise, which is clockwise. So, yung net torque nito, ang direction ay nasa negative k hat direction. Okay. So, yun. Kung nalilito kayo sa direction, again, use your right hand rule kahit ilagay nyo sa screen nyo yung right hand nyo para makita nyo na, ay, counterclockwise, pag ganon. Pag ganon. Okay. Tapos yung resulting torque niyan is out of the page. Kapag naman clockwise, yung resulting torque nito ay into the page. So, papasok. So, usually this is positive k hat. Ito ay negative k hat. And otherwise, unless otherwise stated. Okay, so normally, or usually ganyan naman. Or pagdating naman sa exam, ibibigay naman yung ano yung positive direction and negative direction. Okay. So with that, I think that's it for lectures 21 and 22. So sana may na-learn kayo. And if may questions kayo further, you can just ask your instructors, your respective instructors about the problem. Okay? Thank you for listening and good luck.